Hello everyone, me again. Following on from last week's video on subtractive manufacturing, this one's going to be about 3D printing instead. We're going to be building a robo hand. Let's get started, shall we? Item? What the? That's better. Okay, totally forgot what I was thinking about there for a second. What was I talking about? Oh yeah, that's right, 3D printing. Now, the Mark 1 prototype is designed and knocked up in an afternoon, and consequently some of the parts are a bit blocky and overly complicated, like this joint for part of the thumb. But despite all that, it was a good proof of concept. However, there were still some issues. For instance, there was no way to adjust the positions of the knuckles once the design had been put together. This was fixed in the Mark II version by putting the knuckles on the end of long ball joints. The design of some of the parts was also changed to minimise the number of steps required to build each component. But the design was still a bit blocky, so in the Mark III version I rounded off some of the edges and made some cutouts in some of the components to try and minimise the construction costs a bit. It was at this point that I placed an order for the Mark III hand through Shapeways, and started work on the Mark IV, where I mostly tried to reduce the amount of plastic used even more by shelling out parts of the fingers and some of the other joints. However, there was a problem in the design with the knuckle joints. What happened was I'd forgotten to account for the fact that this hole is smaller than this hole, so the pins didn't quite fit. Hey, do we still have that footage of me on the lathe? We do? Okay, great.
I didn't actually make the right size pins for the hand. I'm going to make some out of this brass bar I've got lying around. Power feed on. And there we have it. Just got to cut that off, and there's a replacement pin bearing.
About 2 weeks later, the finished product arrived in the post, and other than me forgetting to make the right pins for the knuckle joints, it all fitted together quite well. I was surprised that parts that my precision fit and had no tolerances at all still slotted together without any issues. Every joint in the finger is held together by a pair of little tiny plastic pins. All the fingers in the hand are attached via ball joints, so the knuckles can be fine-tuned and then glued in place later on. I went through several different mounting designs for holding the servos for the hand, the most recent of which use little tabs to help make assembly a lot easier because all the parts just slot into place without the need for any screws at all. And this was a big advantage over the previous design, which didn't have any tabs at all, because 3mm MDF is very thin. Trying to screw it edge on is very difficult without the tabs. In addition to the servo frame, there's also a tapered cover which sort of goes over the top of the servo mounting frame that the hand gets bolted down to. This cap is held onto the frame with hot melt glue, because for all the odd angles there's no real way to use screws to hold it down. Once the cap's glued down on top, the hand then gets glued to the cap and the servos get just slotted into the racks. They haven't got any specific positions, because the idea is you can slot them up and down in their little slots to adjust tension on the cables later on. Each finger has a total of 4 control cables and 4 little Teflon sleeves, which help sort of guide the control cables to where they're needed. Once all the sleeves have been tacked in place, they're then cut to length, and all that's left then is to feed the control cables through the sleeves, time to the servos, and screw the servos in place. I did order the Mark IV too, but it didn't arrive in time for the show. Although the Mark III came out pretty well in the end. Here you can see all the control cables tied into their respective servos. And that's all from me for this video. I hope you found it interesting. See you next time.